So somebody had a question about equivalent mass in class today and what it really is and why it's important. So we all know that some acids, so let's use HCl, right? When they break down into one proton and one conjugate base. And so we have that. Some acids will actually break down into, we'll have two protons that they can donate. And you guys know that, right? And so that we might have a diprotic acid where it releases two of our protons. And so what our equivalent mass is really asking is, what is the mass of acid that it takes in order to donate one proton here? And so for HCl, if we look up the, let's see, the mass of HCl, we'd have 1.01 plus 35.453 grams, which would be our mass. And the molar mass of HCl is 36.463 grams per mole. Well, I know that when HCl breaks down, it's going to give up 1 mole of H+. So if I had 1 mole of HCl, I'm going to get 1 mole of H+. I'm also going to get 1 mole of Cl, but we don't really care about that right now. And so what that tells me is that if I weigh out 36.463 grams of HCl, that is going to give me 1 mole of H+. And so that would be my equivalent mass. So my equivalent mass of an acid is equivalent to the grams of the acid over the moles of H+, if that makes sense. So in this case, I would have my equivalent mass for HCl would be 36.463 grams of HCl, and that would give me 1 mole of H+. So my equivalent mass would be 36.463 grams per mole of H+. Oops, you can't see that. Right? It's pretty straightforward. But let's say you had a diprotic acid. So let's go ahead and look at one from our pre-lab. So let's go ahead and look at pre-lab question number 1. And let's look at 1C, because this one is a diprotic acid. So here we have sulfuric acid, H2SO3. And there are actually 2 ionizable protons. And I'm going to be left with SO3 2 minus. And so here I know that for 1 mole of H2SO3, I could get 2 protons off of that. And so we're going to plug that into this equation up here, because I know my equivalent mass is going to equal the grams of acid over however many ionizable protons there are. So here I have the molar mass for this is 82.08 grams. There are 2 ionizable hydrogens per mole of H2SO4. And so basically I'm just dividing 82 by 2, right? So I'm going to have 82.08 divided by 2. And my equivalent mass is 41.04. So in 41.04 grams of H2SO4, I'm going to get 1 mole of H plus, right? Gram. So that would be grams per, sorry about that line, per mole of H plus. There we go. That would be my answer. So that's all equivalent masses. I hope that clears some things up. Let me know if you have any more questions tomorrow.